Good evening, Rancho Verde High School pre-calculus students. This is Mr. Langston coming at you this evening. We are doing section 2.5, which is the zeros of polynomial functions. But before we do anything, we have a nice little warm-up for you. So you have simplify 2 minus I, 3 plus I over 3 plus I. Sorry about that. So to do this, first thing we are going to do is I'm going to switch to this color. We're going to multiply both the top and bottom by the complex conjugate of the bottom imaginary number. So we got 3 plus I, so its complex conjugate is 3 minus I. And we're going to do both top and bottom by that complex conjugate, 3 minus I. So now what we're going to do is just straight up multiply. Now the way I multiply is I use the stacking method. So I have 3 plus I over 3 minus I, and I just multiply like I would normally multiply. Negative I times I is going to be negative I squared. Negative I times 3, negative 3I. Put a placeholder there. We're done with the negative I. So we got 3 times I. Well, that's positive. Positive 3I. And then 3 times 3 is 9. So when we add it together, middles cancel out. We have 9 minus I squared. I squared's negative 1. So it's 9 minus a negative 1, or in this case, just 10. So the bottom becomes 10. And now we're going to multiply again the tops. And I'm just making myself some room. So to multiply the tops out, you have 2 minus I times 3 minus I. So that's going to be positive I squared. Negative I times 2, negative 2I. Placeholder, 3 times negative I, negative 3I. And then we have 3 times 2, which is 6. So we have 6 minus 5I plus I squared. Now remember that I squared is negative 1. So plus a negative 1, these two can be combined. 5 minus 5I. So that's over 5 minus 5I. And now let's make myself some more room. Okay, there we go. And now we put everything under 10. So I have 5 over 10 minus 5I over 10. And that becomes 1/2 minus 1/2 I. And there you go. So you've got to solve x squared minus 2x minus 63 equals 0. So we can use the magic x, but the reality is, since our last section was, how do I put it, complex numbers, I'm going to pretty much assume that it's not factorable. So I'm just going to use the quadratic formula. So we got x equals negative b plus or minus square root b squared minus 4ac, and that's all over 2a. So I have x equals 2 plus or minus square root of 4. I just squared it out. What can I say? I'm just that awesome. Minus 4 times 1 times negative 63. Okay. All over 2 times 1. All right. So I have x equals 2 plus or minus square root of 4. Now, I've got negative 63, so I'm just going to add whatever 4 times 63 is. So 4 times 60, that's 240, and 4 times 3, that's 12. So I've got 252, and it's a plus, so guess it's not going to give me imaginary. Oh well. And that's all over 2. So I've got x equals 2 plus or minus, so that's square root of 256 all over 2. Now, 256, I know, see, 2 to the 5th, that's 32. 2 to the 6th, that's 64. 2 to the 7th is 128. 2 to the 8th is 256. So that means that this 2 plus or minus square root of 256 is going to be 2 to the 4th. And I don't know why I wrote that square root sign. So that's just 16 over 2. And now I've got 2 plus or minus 16. So I can split that up here. And I'm going to mosey along right over here on this side. So I've got 2 plus 16 over 2. And I've got here 2 minus 16 over 2, because this is plus or minus. So what I'm doing is I'm just splitting it up. Now 2 plus 16 over 2, that's 18 over 2, which is 9. 2 minus 16 over 2, that's going to be negative 14 over 2, which is negative 7. So x equals 9, x equals negative 7. There you are. I've cleansed the daemon. And let's go on. So we got section 2-5, zeros of polynomial functions. Our focus standard, of course, zeros of polynomial functions. Content standard, we're still in chapter 2, polynomial and rational functions. What are we going to use for our power standard? We are going to utilize structure. So you're going to use the structure of a problem to help you find an answer, and at the end of the lesson, you are going to be able to verbalize the rational root theorem, and you'll be able to document your understanding in haiku learning. So let's go on. So you have the zeros of polynomial function. It's called the rational zero test. I never learned it as the rational zero test. And in fact, I've never even seen it called the rational zero test. What I have heard it called is the rational root theorem. Now, what the rational root theorem says is that all your roots, all your real roots, are going to be a ratio of p over q. Now, what's p? P is the factor of the constant, or basically the last term. And that's with x to the 0 power, or just the number. And q is the factor of the leading coefficient. Okay, so what I'm talking about is this. If I have this equation right here, this function, it's 1x to the 4th, and then I have negative 6 back here. Our p's are back here. Our q's are up here. Now, for p, I don't even know why it does that. Every now and then it just does that. I don't know. So for p, we take the factors of negative 6, okay, or just 6. When I factor it out, I've got 3, 2, but I can also factor it out to 2 and 1. So the factors are 6 are plus or minus 6, plus or minus 3, plus or minus 2, plus or minus 1. The factors for q, we just take the coefficient of the leading term. So for q, it's just plus or minus 1, because 1 using a factor tree, all I get is 1 and 1. So nothing exciting there. Now, all our roots are going to be a ratio of p over q. So p over q, that basically means everything divided by 1. So 6 over 1, which is 6. So I don't really need to worry about that. I'm just going to put them in ascending order now. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And that's our factors. So next thing we've got, you need to find these roots. I'm sorry to say it, guys. You're going to have to plug and chug. So start off with something easy to divide by. You can divide by 1 or negative 1. Go ahead, use your synthetic division. So dividing it by 1. I've got, first off, my root, let's see, my terms are 1, negative 1, positive 1 again, negative 3, and negative 6 right here. 1, negative 1, 1, negative 3, negative 6. So this is basically trial and error. And I know it sucks, but whatever. Can't do much about it. So 0, 0, 1, 1, 1, negative 3. So I got negative 2, 1 and negative 2, negative 2. Well, guess what, you guys? It's not 1. So I can get rid of 1. But we got to try negative 1. So let's try negative 1. So I got negative 1, so negative 2. I'm at 2. So I got 3. So now I have negative 3. So I'm down to negative 6. And I got negative 1 times negative 6, positive 6, 0. Shazam! So right here, I have a root of negative 1. Okay? Now, if I make it into the term, I have x plus 1. Because remember, when I set it equal to 0, I get a root of negative 1. Now, I can take these terms now, and this becomes basically, if I wanted to write it, this becomes x plus 1 times, and this is x cubed minus 2x squared plus 3x minus 6. Now, I can divide into this, but this is already here. So I'm just going to keep this, and I'm going to continue on dividing. I'm going to try things. So I already know I'm not going to have a root of x is 1. I already know I'm going to have a root of x equals negative 1. I need to find another root. Maybe x equals negative 1 will work again. I don't know. I haven't ruled it out until I can't divide it anymore. So I'm going to try negative 1 again. Bring down this 1. Let's try it. So negative 1, so that gives me negative 3. That gives me positive 3. That gives me 6. And then that gives me negative 6. And that gives me negative 12. So x equals negative 1 is not a root anymore. Sucks to be me. All right, it was worth a try. It actually kind of looked promising, almost. What can I say? So we got to find something else. Unless I did anything wrong. Let me see. Negative 1, so that gives me negative 3. Gives me positive 3, 6, negative 6. Yep, pretty much that's that. So let's try something different. Let's try, I'm going to keep my negative. I want to try negative 2. I don't know. So negative 2 times 1 is negative 2. So that gives me negative 4. Negative 2 times negative 4 is 8. That gives me 11. I really don't think it's negative 2. So that gives me negative 22. Yeah, no, that's not working for me. So let's try positive 2. So let's try that. So 2 times 1 is positive 2. That gives me 0. So that gives me 0 here. Drop down a 3. 2 times 3 is 6. Shazam! Okay, I have a remainder of 0, so x equals 2 is a root, and I can describe this as x minus 2. Okay, so I got 2 more roots. What this is going to look like now is I have x plus 1 times x minus 2 times x squared plus 0x plus 3. Well, now what I can do is just straight go to the quadratic formula at this point. Okay, so I can say x equals negative b plus or minus square root b squared minus 4ac, and that's all going to be over 2a. So x equals, well, I'm going to get 0 plus or minus square root of 0 minus 4 times 1 times 3 all over 2 times 1. Well, the zeros already canceled out. I don't have to worry about it. Shazam here, shazam there. I got negative 12. So that's going to be 2i root 3, or 2 root 3i, however you want to put it. I don't care. So you have x equals 2 root 3i, and understand it's plus or minus because I have a plus or minus here. I'm just bringing it down. And that's all over 2. So cancels out. X equals plus or minus square root of 3i, or I root 3, however you want to put it. So I now have my root of, oh, it only asked us for the roots. So my root is going to be -1, +2, positive I root 3, negative I root 3. And there I go. That's some of my roots. And that's all that was asked, right? Let's just check. Find all the rational roots. Yep, that's it. So moving right along. You need to find the rational roots. Same thing. Different type of problem, same thing. So you have 2x cubed plus 3x squared minus x plus 3. So first off, I got my p's. I got my q's. Now, my p's are plus or minus 1, plus or minus 3. My q's are plus or minus 1, plus or minus 2. So my p over q, first off, I'm going to take if they're divided all by 1. So I got 1 over 1, which is 1. So plus or minus 1 and plus or minus 3. Now, what if 2 is the bottom number? So I've got plus or minus 1/2, and I have plus or minus 3/2. So those are my p's over q's. That's my ratios. Some of these, maybe if I have a real root, it's got to come from one of those 8. Hopefully, it's one of these nice numbers. Realistically, I bet you it's one of these numbers. I bet one of these numbers are there too. So I don't know. Let's find out. Start off with your synthetic division, dividing by 1. I always do. So I've got 2, 3, -8, 3. 2, 3, -8, 3. So bring down your 2. I got 1, 2, so that's going to give me 2. That gives me 5. 1, 5 is 5. And I got -3. 1 times -3 is -3. 0. Shazam! Okay, right there, I know x equals 1 is a root. And my little equation thing is x minus 1. So, I got 2, 5, -3. At this point in time, I'm just going to switch to the magic x because I'm feeling a bit lucky this time. So I'm going to do 2 times -3 is -6 and 5. Two numbers I multiply to -6 and add to 5. Well, you've got +6 and -1. Now, because I have a coefficient of 2 here and not 1, I'm going to put over 2x over 2x, and I'm going to see if I can simplify. I can't simplify that, so it stays like that. I can simplify this. This becomes 3 over x. Okay, so my term here becomes x minus 3, or sorry, x plus 3, and my term here becomes 2x minus 1. So what I have is x minus 1 times x plus 3 times 2x minus 1. Now that's the factored form of f of x. So I already know x equals 1, x equals -3, and x equals 1/2. Look at this. I've got 1, -3, 1/2. So again, all my real roots are going to be one of these ratios or some of these ratios. So talking about conjugate pairs, if a plus bi is a 0 of a function, then a minus bi is also 0 of a function. So this is what it really says. It says, if you get an imaginary root, then guess what? Another root is its conjugate. Imaginary roots always come in pairs of 2, whatever the root is and the conjugate. So find a 4th degree polynomial function with the real coefficients that has with the real coefficients that has -1, -1, and 3i as zeros? Well, because of this, I've got an imaginary number 3i. I automatically know I have another imaginary root, -3i. So, all right, cool, works for me. So what it's saying is my function f of x is going to be x plus 1, x plus 1, x minus 3i, x plus 3i. And now I need to make this, I just basically need to multiply to make it into a fourth degree polynomial. So this becomes x squared plus 2x plus 1, because I multiplied it out and I have this memorized here. X plus 1, x plus 1, x squared plus 2x plus 1. Just multiply it out, do the stacking method. This one becomes x squared, and now you've got -9i squared, so that's going to just become +9. Okay, so we have that there, x squared plus 2x plus 1, and then x squared plus 9. And now we have the pleasure of just straight up multiplying this out. So stacking method, x squared plus 2x plus 1, x squared plus 9, don't forget your placeholders. So x squared plus 0x plus 9, and then just straight up multiply it out. So you've got 9, you've got 18x, you have 9x squared, placeholder 0, 0, because again, this 0 times everything is just 0, so I'm just going to put a double placeholder. And now I have x squared, 2x cubed, and then x to the 4th. Now when I add this all together, I'm going to get x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. So again, I'm just going to rewrite it over here. X to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. Yay me, I've cleansed the demon. All right, so going over here, you got to write f of x equals x to the 5th plus x cubed as a product of linear functions. So basically what it really wants you to do is write it like this. So you really got to find the roots and then just write it like that. No big deal. But we got to find the roots, and it's a 5th degree polynomial, which yay. So you got your p, you got your q. So I'm going to start with q. That's easy. It's plus or minus 1. Yay, that makes everything easier. However, our p's, when I factor out 8, I'm just going to do it here and I'm going to erase it. So I got 2, 4, 2, 2, and then remember, you'll always get a factor of 1 as well. Okay, so all my factors, 8, 4, 2, 1. So plus or minus 8, plus or minus 4, plus or minus 2, plus or minus 1. So that means, and I'm going to erase, so P over Q, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Please, Lord, do not let it be 8. So we've got to do our synthetic division. So we're going to try 1 first because, well, we always do. And let me see. It skips an x to the 4th, so it's 0x to the 4th. So I've got 1, 0, 3, 2, -12, and ocho. So bring down your 1. 1 times 1 is 1. 1, 1, 4, 4, 6. Ay, that ain't going to work out. 6, and that's going to give me -6, and then -6 gives me 2. So guess what? Our root's not 1. Let's try another one. Let's try -1, make our life easy. So -1, -1, +1, 4, negative 4, what is that, negative 2? I'm tired. Negative 2, negative 1 times negative 2, positive 2. So that's negative 10. And now we got, well, SOL on that one. Sorry, out of luck. So 10, I've got 18. So let me just make sure my numbers are coming out right, because ones are our favorites. So negative 1, negative 1, positive 1, 4, negative 4, negative 2, positive 2, negative 10, positive 10, 18. Yep, definitely not that. So let's go for 2, I guess. Do you see how much fun this is? This is just the greatest. Yep, I didn't like it either when I learned it. So you got 2, 2. Okay, I can pretty much say it's not 2, I think. Oops, sorry. 2, 2. Yep. 4, 7, 14. So that's going to give me 16. And now 2 times 16, 24, 12. Yep. Not a good one. Let's try negative 2. So that's going to give me negative 2. And that's going to give me 4, 7. So much fun. Just so much fun. Negative 14. 2 times negative 14. Negative 12. Positive 24. Negative 12. And so that's going to give me positive 24. Nope. I want to make sure I didn't mess up on 1. I'm just going to try it again. So 1 times 1 is 1, 1, 1, 4, 4, 6, 1 times 6. Ah! I see my mistake. Ha ha. I hope you caught it. Did you catch it? You've been watching it thus far. Look, I wrote down 3. I'm not supposed to write this 3 here. This is x cubed, but it's 1x cubed. Ha ha. Ha ha. Yep, nobody's perfect. So let's try that now. 1, 1, 1. Okay, comes down. 1 times 1, 1. Comes down, 2. 1 times 2, 2. Comes down, 4. 1 times 4 is 4. Comes down, negative 8. 1 times negative 8. Well, that's negative 8. Gives me a remainder of 0. Boom! There you are. X equals 1 is a root. And I have my equation as x minus 1. Okay? So, makes things better. Let's try 1 again. No guarantees it'll work twice. Let's see. So 1, 1, 2, 1 and 2 is 2, 4, 1 and 4 is 4, and that gives me 8, 1 and 8. Oh, it works again. Knocks it right out. Oh my God. So x equals 1 is another root. Yay! Oh, this is working wonderfully. What can I say? It's a double root. We have a multiplicity of 2. So I've got x minus 1. And now let's do it again. I'm actually kind of thinking I'm pressing my luck, trying for a multiplicity of 3. So let's try with negative 1. I don't know. Again, your guess is as good as mine. So let's find out. Oh, you're asking yourself, wait, Mr. Langston doesn't know the answers of these? No, I actually don't solve the answers ahead of time. I like the surprise. I think it's nice. So negative 1 times 1, negative 1, bring it down. I got a positive 1 here. Negative 1, bring it down. I got a positive 3 here. Negative 3, bring it down. I've got a positive 5. Well, what do you know? Not it. So -1 isn't a root. Let's try let's try 2. So that gives me 2, 4, 8, 12. Well, I can tell you that's not it right there. Not going to be it. Let's try -2. Seems interesting. So -2, 0, 0, 4. What do you know? -8, remainder of 0. X equals -2 is a real root. Oh my God. So that's going to give me x plus 2. And now I've got, basically, if I rewrote this, I have x squared plus 4. Well, I can already tell you, if it was a minus, that'd be great. It would be the difference between two squares. It's not the difference between two squares. So that being the case, magic x, not going to do it. You're going to have to go to our old favorite quadratic formula. So x equals -b plus or minus square root b squared minus 4ac, and that's all going to be over, say with me, 2a. Yes, thank you. Thank you. I'll be here all night. So -b, so that's going to give me 0 plus or minus the square root of 0 minus, and now I have 4 times 1 times 4. And that's all over 2 times 1. So, nice thing is, I don't have to worry about this. Well, not that. I have to worry about the plus or minus part. Just don't have to worry about the 0. Don't have to worry about that 0. So I end up with x equals plus or minus square root of -16 over 2. So that's going to give me plus or minus 4i over 2. So that's plus or minus 2i. So now I have my roots. I can write it as a product of linear factors. So I got x minus 1, x minus 1, x minus 2. So that's x minus 1 quantity squared, x minus 2. And now I have x plus 2i, x minus 2i. Those are the linear factors. Yay, we're done. Okay, so that's about it. It's the last problem of the section. You see, one mistake can hose you down. I wasn't paying attention. Instead of putting the coefficient, I put the power. And boom, there I went. Everything was wrong. So, glad I figured it out. That's about it, you guys. I'm going to post it like this instead of editing out my error, because you know what? We all make mistakes, and I'm cool with it. Doesn't bother me. I think it's encouraging for you guys, because understand that, hey, if your teacher can make a mistake like that, so can you, and it's going to be okay. The world's not going to implode. All right, that's about it. Talk to you later, you guys. Take care and peace. Bye. And by the way, do your homework. All right, bye.